All right. So 280-inch pipe. You want me to write that a little bigger? 280-inch pipe cut into two pieces. That's all we need. You know, how long? Basically, how long is each of the pieces? So 280-inch pipe cut into two pieces. Find out how long each of the two pieces is. So how do we do that? How do we figure that out? Oh no, I'm sorry. There's one key important piece I'm missing. Sorry, there is another important part. One piece is 4 times the other. That's important. Sorry. Otherwise, yeah, we can just divide it by 2, but not without 4 times thing. All right, so one piece is 4 times the other.
So you would go 4x plus 1x, and then divide that into 280.
Yes, very good. So that's the plan. Yeah, when they say one piece, basically here's how, well, this whole section is going to be word problems. When you do word problems, you're always going to let one of the items be x. Plain, simple x. Let me mention that. First item is always just plain x. The other one, and that's pretty much in every word problem. In almost every word problem that you encounter. So these are our, first official word problems here. It's a whole section of word problems. So you always let the first item be plain, simple x. Nothing more complex than that. And then the other item is whatever they're saying. And what are they saying on this one? 4 times. So the other item will be 4 times x. That's the other one. And then, from there, what are we going to do? 280 is the total length, right? So it's kind of like we've got this pipe. And well, it's not good enough. So it's this long pipe. One section of it, say from here to there, is x. And then the rest of it is 4x. Does that make sense? We have this pipe. One section is x. The other is 4 times that amount, 4x. And together they add up to be the whole 180, don't they? X plus 4x is 180.
280.
Oh, 280. Sorry. 280. See what I'm doing there? The mistake, and then we'll just solve that equation. But before we do, I just want to make sure. The mistake I often see, say on an exam, is I'll see people go, oh, yeah, 4 times. I know what I got to do with that, 4x. And they'll go, 4x is 280. And that's wrong. They're missing the other x. How do we know we need that other x? Well, because that's the other piece, right? One of the pieces is x. The other piece is 4 times x. And together, the two pieces add up to be the 280. Does that make sense? Or just simply think this way, because I know you can't always grab everything perfectly with your mind, but just know this in advance of every word problem. Plain x is always going to be a part of it. There's always going to be a plain x. So that'll keep you from this mistake, I think. If you start to go 4x equals 280, just remind yourself, go, no. There's got to be a plain x also. There always is. There always is a plain x also. And then you'll probably remember, oh, yeah, x plus plain x. So you got to have them both. So there's our little equation. Now we need to solve it. Here's the wall. What do we do to, you guys did a bunch. Did you make it through all those fraction homeworks and 2.3 and whatever it was last night? Yeah.
Combine the like terms?
Yeah, right. Combine like terms, right? When we have x's on the same side, they just get together. They just add together. What's in front of this plain x? The ever-present invisible 1, right? So 1x and 4x? 5x. And then last step for solving for x is always divide. That's right. And x is some big numbers. 56? 56, yeah. Now, they're going to ask us for the shorter piece and the longer piece. So we all good to hear so far. We got x is 56. So they're going to want us to find the shorter and the longer. How do we do that? Well, one of them is what? Just x. That's the shorter. The other is 4x, isn't it? So one of them is x. That's going to be 56. The other is 4 times 56. What is that, 224? 224. Those are our two pieces. That makes sense what I'm doing there. So I just took that 56 and I just plugged it in for x right there and then right there in the formula. And those are our two answers. 56, the shorter is 56, the longer is 224. And we're done. Questions I can answer on that one? All right, so what I want to emphasize again, every one of these word problems, plain x and then an x formula. Plain x and then an x formula. Plain x and some kind of x formula. And the x formula will always be given to you in words. Like they'll say something like 4 times as long, or they'll say, the other piece is 4 more than the 4. What if they said 4 more instead of 4 times? What would that be? X plus 4. More's add, huh? Or they said 3 feet less. X minus 3, right? So they'll say more, the other one is more or less or times. And so that'll tell you the other formula. But remember, the main thing people forget is there's also a plain X. Always a plain X as part of the formula. I mean, I guess it technically is. Okay, so this one, you know, in a recent year, the cost of 5 small boxes of a certain cereal was $17.50. So 5 boxes cost $17.50. How much did 1 box cost? You know what? I wouldn't even use an X. You know what to do with this problem, right? What do you do with? So 5 boxes cost $17.50. How much does 1 box cost? What do you do? Just divide. Yeah, I'm not going to do any X stuff. I'm sure if you clicked on Math Excel, they would show you some X stuff. Now, this one isn't worthy of it, right? Now, I don't care how you do the problems, by the way. Do them any way you want. And this one, just divide, right? Just take your calculator and divide. That's why, I mean, it's not really a word. But we don't really need an X, so I'm not going to use one just to do it. What is that answer? 150? Oh, I'm just way off. It's not 150, sorry. Is it 350? No, it is? Thank you. 350, we're done. Simple. So if you can just do that, do that. That wouldn't have worked on the last one, would it? We had to do more complex stuff. Good, that's just a divide. That's not even really a word problem. Okay, if I flash off that? Okay, so this one will be a real word problem. All right, so the height of a building is 936, which, oh, this one isn't a word problem either. All right. Well, which is about 530 feet higher than another building. Find the height of the second building. I'm not going to use an X here either. Yeah. Do y'all see that? So the first building is 936. The second is 500 and... Oh, no, that first one is 530 higher than the other. So you just subtract, huh? Does that make sense? It's funny how they gave us a real word problem at first, and now they're just giving us ones that you don't need. There we go. Done. 406, right? Just subtract, because the first building is 936, and that is 530 higher than the other. So you got to subtract 530 to get the other building. Is that good? So again, that's not really what I would call a word problem. We don't really need X, in other words. It's just a subtract. Is that okay? I'm going to keep moving rapidly because there are word problems. All right, so we've got this dog race thing. It's 1,049 miles from A to N, Anchorage to Nome, in Alaska. If the musher is 4 times as far from Anchorage as from Nome. So the musher is 4 times as far from Anchorage as from Nome. How many miles done? How many miles completed? All right, how many miles completed? So, a little picture might help on this one. Let me draw a picture. So we've got Anchorage and Nome. It goes from Anchorage to Nome. All right, and that's a total distance of 1,049 miles. 1,049 miles. And the musher is 4 times as far from Anchorage as from Nome on that.
Can you just take the 4 times as far and consider that 4 lengths and then the additional length to get to Nome and say it's 5 and divide it by 5?
Yeah, what do y'all think? What do you think we should do here? Where basically, what feel do you get from this sentence right here? The musher is 4 times as far from Anchorage as from Nome. So first off, in the scale of things, is he kind of like in the middle, or is he closer to Anchorage? Is he closer to Nome? Just first off, what's your general feel from that sentence?
It's gotta be longer than that.
He's way over here, close to Nome. Is everybody good with that? Because he's far from Anchorage. He's 4 times as far from Anchorage as he is from Nome. Right? In other words, he's like way over here, somewhere like here. And this is, just like Alex is saying, these 2 distances, here's the musher right here, way over there close to Nome, close to the end of the race. How do we know? Because he's 4 times as far from Anchorage as he is from Nome. He's way further away from Anchorage than he is from Nome, right? 4 times as far. So what do you do with 4 when they say 4 times? There's going to be a 4x somewhere, right? And that's got to be right here. And so guess what this part is? Because there's always a plain x somewhere. So it's just like Alex was saying, right? It's going to be 4x and another x. And yeah, I mean, I'll write the equation now. 4x plus the other x, what do they add up to be? The 1049. Because that's the whole distance. Does that make sense? So it's a lot like the pipe problem, isn't it? 4x plus x is the total distance, 1049. That good? Solve that equation. 4x and understood 1x, 5x is 1049. Last step in solving for x, divide. So x equals some number. 209.8? Thank you. 209.8. Okay. So we got it. 209.8.
That's X.
Good.
Would be
If
solving
I-
for 4x.
Exactly. Does everybody see that?
Okay.
Yes, if we try to say at this point, the final answer to the problem is 209.8.
And it says round to the additional number.
Not time to round yet. 209.8. We're not right. Why not? Well, you always got to be careful on the word problem to answer what they ask for. The answer to a word problem is not always what x comes out to be. Sometimes you got to use that x to get something else, right? So you got to be really careful. What is it they're asking for? What is it they say up here? How much has the musher completed? Even right here. How many miles completed? How many miles completed? Well, where's that? How do you know how many miles completed? Is that not x? Yeah, it's the 4x. See, the 4x is how far he's gone. X is how far he has left to go. Huh? See the picture? So you just want to be careful to actually answer their question. They're saying how many miles. So once you get x, that's not necessarily the answer to the word problem, but that is the key. Excuse me. It'll unlock any of the doors you need. So what door do we need? We need 4x. How far is 4x? And so plug x in, 209.8. So don't round till the end. So don't round right now. Don't round that 209 to 210. It'll mess you up. Don't do that. Keep it 209.8 till the very end, and then plug that in, and then use your calculator. 4 times 209.8. What is that? 839.2. So now we'll round 839 miles. He's 839 miles from Anchorage, right? Because he's almost done. That makes sense. 839 out of the total 1049. He's far into the race. And there we go. Is that good? Making sense on that? Kind of like the pipe problem. So watch out when you're done with the word problem. X is not always your answer, right? Sometimes it is, sometimes it's not. Just depends on the word problem. How do you know? You just got to look at what they're asking for. How many miles completed? That's 4x. So just plug that in. All right. They're just throwing all different kinds of word problems at us here. So some of the page numbers on facing pages of a book is 77. What are the page numbers? Well, if you take a book and you open it up and you're looking at facing page numbers, what do you know about those two numbers?
They're one.
Like say I open up a book and I go, hey, this is page 73. So what's this page?
Consecutive.
Yeah, it's one higher, huh? So they're just being fancy to say, hey, we're thinking of two numbers and one's one higher than the other. That's basically what they're saying, huh? Facing pages in a book, that's just they're just being tricky. That's just a tricky way to say, hey, we're thinking of two numbers and one number is one higher than the other. So what am I going to do with that? Let me start. What do we start with in every word problem? One of them's x, huh? So that'll be the first page. Or the left page or whatever, you know. And then what's the other page?
X plus 1.
X plus 1, that's the second page. Does that make sense? Because one is one higher than the other. But I don't know what either one is, so I got to use x and then one more than that, x plus 1. You see what they're doing there? Does that make sense? And then where do we go from there? What do I do with that x and that x plus 1?
Combine them in.
Sum is 77. What does sum mean?
Equals. Subdivision.
It means adding up to equal 77. See how we came up with that? See how in every one of these word problems, one of them is just x? So the first one's always just x, isn't it? Right? The first one's always just x, and then there's some kind of x formula, right? Look back at the gnome problem. One of them was x, one of them was an x formula, right? Same kind of thing. One of them is x, one of them is an x formula. All right, can you solve that equation? For x there. Go ahead and solve that equation. I'll give you a second. All right, so combine like terms, x and x. 2x. Like that. And then x is saying I want to be alone. Subtract the 1. Because you're gone. 2x is 76. Last step to get x alone. Divide by 2. X is, what's that, 35? 38? So the page numbers are 38 and 39, aren't they? 38 and 39? Because it's x, and it's x add 1, right? Is that good? Am I going too fast? Is it making sense? I'm always trying to keep that edge of get us through the material but not rush too much. Is that okay? Questions on that? I know word problems can be challenging. You can do word problems. You know, there was a time when I thought I couldn't do word problems. Right? I mean, I'm always because sometimes you think there's this idea that you're either a math person or you're not, and if you're not, you just can't do it. No, that's not true. You can do this. There was a time when I thought I couldn't do word problems, but truly I just wasn't working at them. That was the truth. It took work. I had to work hard, but I was just not wanting to work hard, was the truth of the matter. You can do them. Practice them. They take time, though. They will take time. You can do them. All right. Consecutive integers. Let me show you that phrase. So, when they say consecutive integers, numbers is just numbers. Consecutive means numbers in a row, right? So that'd be like 17, 18, 19. Or, 26, 27, 28, whatever. It means three numbers in a row. So consecutive means in a row. Now, I don't know what they are in particular. So, what's the first one going to be? Like, what's the first one in every word problem? X is the first one. So, what's the second one going to be? X plus 1. There's the second one. And what's the third one going to be? Yeah. See how it just goes up by 1 every time? You start with x, first thing in every word problem is x, and then you just add 1, because that's what consecutive numbers do. They just go up by 1 every time, don't they? And the sum of their ages is 120. So let me give you a second rather than me just diving in. So take those three and put them in an equation. All right, y'all got that? So x plus 1 plus x plus 2 equals 120. Add them up like that equals 120. Is that good? Because sum means add. So add them up, it equals 120. So now what is that? X plus x plus x is 3x. And 1 and 2 is 3. We good to there? And then x going to want to be alone, so you know the drill, right? Subtract 3 from both sides. And these are gone, so 3x equals that 117. Last step is divide. So x equals something. 33 and 6. Is it 39? Yeah. X is 39. And now, what does that mean the three numbers are? 39, 40, and 41. There must be their three ages. Is that good? Is making sense, these word problems? So consecutive means in a row. Just add 1 every time. Questions before I flash off of it? Good? All right. They're giving us every variety. This is a challenging section. So, okay, so now they're going to say 3 consecutive odd. So instead of just 3 consecutive, they're saying 3 consecutive odd this time. So that's what they're changing. So last time they said 3 consecutive. Now they're saying 3 consecutive odd. Now that would be, let's do it for instance. That'd be like 17, 19, 21. Or you know, 83, 85, 87, etc. 3 odd numbers in a row. That's what they're talking about. There's 3 odd numbers in a row, and they want us to find them. So last time it was just 3 numbers in a row, plain. Now it's 3 odd numbers in a row. What do you notice about odd number to odd number? What's the jump every time from odd number to odd number? Yeah, it always goes up by 2 every time, doesn't it? Now that confuses people a lot of times. Hold on for a second, because when I go over to write the form, well, let's write them first. What's the first one going to be? What's the first in every word problem? X is always the first. Now, what's the second one going to be? If the jump is 2 every time from odd number to odd number, it's going to be x plus 2 instead of x plus 1. Does everybody see that difference? Because the jump is 2 now, not 1. And then what's the third one going to be? Add 2 more, x plus 4. Right? See the difference? Let me flash back. See how last time it was x, add 1, add another 1. We just kept adding 1 every time because that's what you do when you go up by 1 every time, right? With consecutive numbers. When they just say consecutive and they don't say even or odd, like on the last problem, then you just add 1 every time, don't you? Because they only go up by 1 if they're consecutive numbers. But if they say consecutive odd, then they're going to go up by 2 every time. So you start at x, you always start at x, add 2, add another 2, don't you? Now here's a good question I often get. People go, wait a minute, Sarah, wait. This says odd, and you're adding an even number. That's not right, but that is right. Because odd numbers have a jump of 2, don't they? What if they had said even numbers? What if they'd said, hey, these are 3 consecutive even? Let's think about that. That'd be like 26, 28, and 30, for example. If they had said even numbers, what is the jump from even number to even number? Still 2. It'd make no difference. Even numbers and odd numbers jump by 2, don't they? So remember, this 2 and 4 is the jump amount. It's not the number itself. It's how much the jump is from number to number, right? So whether they said even or odd, it's the same story. The jump is 2. We would start at x and just add 2 every time. And if they don't say, like in the last problem, if they don't say even or odd, you just add 1 every time, don't you? Is that good? All right, so coming back to here, let's solve the word problem. So what are we supposed to do? Okay, yeah, the sum, so it's the same thing as last time, right? The sum is 171. So x plus 2 plus x plus 4 is 171. There's the wall. Solve for x. X is 3x. 2 and 4 make 6. To get x alone here, we subtract 6 from both sides. Bring that down. 3x is something. What is that? 165? And last step is divide by 3. And x is 55. X is 55. 55. So the numbers are 55, add 2, 57, and 59. 55, 57, 59.
53. Because 3 in the 150 would be 50, and then 65 would be 15, be 3. Would it be
3 goes into 15 5 times.
Oh, wait a minute.
Good? Good on that? We good? All right. No questions? Is that okay? Did I whip that out too quick? You probably had already done it for me. We good? All right. Perimeter of a basketball court is 96 meters, and the length is 6 more longer than twice the width. What are the length with? Oh, it's a more challenging one. Okay. All right. So it's saying perimeter 96. Length is 6 more than twice width. Length is 6 more than twice width. Find the length and the width. Okay. So a basketball court is a big rectangle. It's a big rectangle. How do we find the perimeter? What's the perimeter formula for a rectangle? Yeah, perimeter. So this would be a good formula to put on your 3x5 card. Well, not for today's test, because this all this material is on the second exam, right? The first exam stopped at 2.4, right? Section 2.4. We're done with all that material. All this is on the second exam, which is next Thursday. It's never long here in the summer. So next Thursday, you'll be taking a test on this stuff. So, yeah, perimeter is 2 length plus 2 width. Looking up here to the rectangle, it makes sense. If this is the length, well, let's just call that width. So if this is the width, and this is the width, and this is the length, then you can tell perimeter means all the way around the object. It's 2 widths and 2 lengths, isn't it? To go all the way around the object. That's what perimeter is. So perimeter formula is 2L plus 2. So you just need to write that formula. This is one of these where you just have to have this on your 3x5 card or in your mind and just know perimeter for a rectangle is 2 lengths and 2 widths. Okay. So now perimeter, so we're going to start. So this is my formula right here. I'm just going to plug into that thing. So perimeter's 96, so that'll go right here. 96 equals, now 2L plus 2W, we're to that point. Good so far? So I just used the perimeter formula, 2L plus 2W, and perimeter's 96, they're telling me. Now, can I just solve this right now? Let's answer that question first off. Can we just solve this right here? Well, the problem is not right now. We got to make a change, huh? Because the problem is we have 2 letters. And we don't want 2 letters, right? I need to have only 1 letter. I don't want 2 letters. Everybody with me? So how do I make that change?
You plug in the 6 and twice the width.
Yeah, look what it's saying up here. Look back at their statement. L is, what is? Equals. That's saying L equals 6 more
Yeah.
added to W. Isn't that what that's saying? Length is 6 more than twice W. I didn't see the twice there. 6 more. In fact, let me just, I'm running out of room there. Let me say it over here. L is 6 more than twice W. Huh? Isn't that what that little sentence is saying? L equals 6 more than, 6 added to, twice W. Okay, so what? What can I do with that? That means this can go right there. Does that make sense? Because that is L. L is that. L equals that. L is the same as that. So that means wherever you see L, you can stick in 6 plus 2W. Because 6 plus 2W is L. It's the same as L. That making sense? So right here, put it back the way it was. Right here, I can say, okay, 96 is 2. Here, let me do it this way so it makes sense. Okay, 96 is 2 times what? Something. Like this. I'm going to put in there 6 plus 2W, huh? Yeah, does that make sense there, what I just did? Did you see that plug in?
I saw it plug in.
I plugged in for L right here, for L, 6 plus 2W. Now the 2 in the front of the L is still there, the 2W is still in the back, none of that has changed. It's just the L itself, because L itself is 6 plus 2W. So the L itself has been replaced with 6 plus 2W, because that's what L is. Is that good? Is that making sense there? And now I've got an equation with only 1 letter and I can solve. How we doing? I'm trying to read your faces. Do you want me to say more about that?
Yeah.
Is that making sense? So again, I just took their sentence. This was their sentence. L is 6 more than twice W. So L equals 6 plus 2W. So what that means is wherever I see L in any formula at any time, I can replace the L with 6 plus 2W because L is the same as 6 plus 2W. Wherever you see L, you've really got 6 plus 2W. So I saw L right here next to a 2. I said, hey, I see an L. He's right next to a 2. All right. Well, right next to that 2, put 6 plus 2W. Because that's what L is. It's 6 plus 2W. Is that good? And now I've got an equation that only has one letter. I can solve it. So I'm ready to go. It's only got W. So I'll go ahead and distribute. Here's my equation now. So 96 is what? 12 plus 4W, and then that 2W is still at the back. That makes sense what happened there. Let me space that out a little bit more. 12 plus 4W plus 2W. That good? So I just put the 6 plus 2W in the place of L. And then I'm bring it over here. So what do we have? We have 96 equals 12 plus 6W. Can I combine the 4W and the 2W to make 6W? W is saying I want to be alone. So what do we do to get W alone? Yeah, subtract the 12. Bless you. And what is that? 84 is 6W. Last step is divide, like always. Divide by 6 on both sides. Is that a 14?
Yes.
14. The width is 14. So you can read that down there. So the width is 14. The width is 14. And how do we find the length? We know the width now. We know the width is 14. How do we find the length?
Plug it into that.
Yeah, right there. Because there's the length formula, huh? So just stick a 14 in right there for W. Now that you know what W is, you have the key to unlock any door. And we can unlock the L door now. L is 6 plus 2W. We know what W is, 14. Plug it in, unlock it, right? So then L will equal 6 plus 2 times 14. And so that is what? 6 plus 28, yeah, 34. L is 34. Length is 34, width is 14. We got it. There it is. Questions on that one? That was a long one. That was a complex one. Does that make sense? So I wrote out the whole perimeter formula. So whenever they give you perimeter of rectangle, right, perimeter is 2L plus 2W because 2 widths and 2 lengths make a rectangle. Then plugged in the perimeter, and then I took their other sentence, L is 6 more than twice W, L equals 6 plus 2W, and plug that in right where L was. Notice when you plug in, everything else stays put. The 2 that's in front of the L is still there. The 2W at the back added is still there. But right where the L was, I put parentheses. Whenever you plug into any formula, it's parentheses, right? Parentheses, 6 plus 2W, right in the L slot. And then I just distributed and solved for W and plug that into the L formula to get L as well. All right, so that was a... All right, so they're putting a lot of different kinds of word problems onto us. All right, so Amy paid $60.50 for a pair of running shoes during a 20% off sale. So the question is, what was the regular price? Let me give you a formula just to help with these like sale problems. So basically, for a percent increase or a percent decrease, because they're going to give us a few of these now. percent increase or decrease problems. So percent decrease would be like a sale, and an increase would be like tax or something. So they'll give you a bunch of problems now. They're giving us like 4 or 5. And they're kind of cookie cutter. They're kind of the same every time. I just want to give you a nice, easy little automatic formula just to plug into every time to make them easy. So basically, if they'll be giving you a lot of tax problems where they say, the price of this computer is, $800, but what 10% tax, so what's the final? Well, that would be simple. They'll make it more tricky. They'll say the final price was $873. And there was a 10% tax. What was the original? You got to work backwards. They'll give you things like that. So anyway, they'll give you a bunch of problems with percent increase, which is like tax. That increases prices, right? And then they'll give you a bunch with things on sale, which is a decrease, right? Sale brings the price down. So what are you going to use? You always use plain X. Remember, every formula has a plain X. Plus percent of X, that's the increase, equals the new price. Or for decrease, it's going to be the same thing with a minus. X minus percent of X is the new price. So I'd encourage you for the second exam, well, that's a ways off. We don't want to think about the second exam right now. We're having the first exam in a couple hours, or in an hour. So, but on the second exam, next Thursday, we'll use these two for you. You should put these on your 3x5 card. All right, so this problem that we're looking at, is it a percent increase or is it a percent decrease?
Decrease because it's on the sale.
Yeah, decrease because it's on sale, right? $60.50, 20% off sale. So this is a percent decrease problem because it's a sale. All right, so I'm going to go, all right, X minus, right? The minus is the decrease, right? When you decrease a price, you subtract it. That's why this has the minus. When you do taxes, you add to the price because that increases, right? So the increase has the add, the decrease has the subtract. So here's my formula for decrease. Now, what's the percentage? 20%. So I always change those to decimals, right? 0.20 or just 0.2 is fine because the 0 doesn't do anything. Equals the new price. Do I know the new price? Like what she paid after the reduction? Yeah. $60.50. Do you see why I'm calling that the new price? That's not what the shoes were originally, is it? That's not the original price. That's the new price after the sale reduced the price, huh? You tracking with me? $60.57, that was the sale price, the new price after the reduction. So there's our little formula. How do we solve that formula for X?
Oh, no, you combine them, right?
Yeah, good. So somehow, looking over here, these guys have to be combined. Well, how do you do that? If I had like 7x minus 3x equals blah, 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 whatever, you would just go, well, 4x. Right? Just subtract the numbers in front of the x's, huh? So what number's in front of this x?
1, so then we won't.
Yeah, the invisible, ever-present, 1. Yeah, if there's no number in front, it's 1 because 1 times x is still just x, huh? So there's really a 1 there. Okay, so let's do the same thing. Let's subtract the numbers in front. What's 1 take away 0.2? What's $1 take away 20 cents? 80 cents, huh? Just like 7x minus 3x is 4x, 1x minus 0.2x is 0.80x, right? $1 minus $1 minus 20 cents is 80 cents, huh? Good to there? Now how do we finish getting x alone? Bring it over here. 0.80x is 60.57. Last step is always divide. So divide by 0.80. And what's the calculator say? 75 straight on?
And 71 cents.
Oh, 75, 71? Other people getting that? 75, 71? No? No, it's got to be bigger. I think you subtracted on x then. So is that right? 75, 71? There we go. So that was the original price of the shoes. Is that good? It makes sense. It's a higher number, huh? Remember the price was higher before, and the sale brought the price down. Is that good? So percent increase, percent decrease. So percent increase and decrease, you take the original price, X, minus a percentage off of X, equals the new price. And for increase, the original price, X, plus a percentage of the original price, the increase, equals the new. So those are formulas for finding the new price after a decrease, subtraction, or an increase, adding, of a percentage of the original. That makes sense. X is the original price. The original price plus a percentage of the original, or the original price minus a percentage of the original for decreasing, gives you the new price after the increase or decrease. All right, so they've been changing. Everyone's been different so far. I think we've about seen all the types, but maybe I'm wrong. Let's see. I can't remember exactly. So employee salary was $17,535 after getting a 5% raise. Okay, so this is one of those percentage problems, right? There it is, 5%. So right away you think, okay, one of those two percentage formulas. Is this one an increase or a decrease? Yeah, raise. A raise is an increase. Huh? So go ahead and write down so first thing to do is write down the percent increase formula. As soon as you see this on the second exam in a week, you see this kind of thing, you go, oh yeah. That's percent increase. So it's X plus percent of X equals new. Sometimes people forget the second X. There's two X's there, huh? So there's your formula. Plug into that. Okay, so it's a 5% raise. What do you do with 5%? 0.05, very good. So it's got to be two places back, huh? So it'd be X plus 0.05X, and the new price is $17,535, because that's the new price after the raise, huh? So there we go. Okay, now these are like terms on this side. What's really in front of that X when there's no number in front is the 1. Now we're adding, huh? It's not $1 take away 5 cents. It's $1 add 5 cents, huh? So it's 1.05x. Is that okay? Like that? Last time it was subtract. And then finish by dividing both sides by 1.05. And so we get, I don't know, 17,000? 16,700? 16,000. That was the salary before the increase. No, that looks about right. Is that okay? Questions on that one? I seem a little bit better, a little more cookie cutter. It's kind of the same thing as the last one. They keep changing it up on every problem, so this one's nice. It's the same thing. No questions? We okay? I'll move forward. Am I going too quick? We get that? So number 12. In a triangle, ABC, the size of angle B is 5 times the size of angle A. The size of C is 14 less than 4 times A. Find the size of the angles. That sounds fancy. It's actually, you don't have to know a lot of geometry or anything like that for this class. It's let me help. It sounds harder than it is. It's actually not that bad. So let's take what they're saying. They're saying B is 5 times A. Let me just write that out real clear. B is, what does is always mean? Equals 5 times A. So they mean B, right here in the B angle, it equals 5A. Does that make sense? Can I just put that right there? Angle B is 5A. Why is it not 5 plus A? Because it says times, huh? So it has to be multiplied right next to it. We good there? And then can you do the same thing for C? C is 14 less than 4 times A. C is 14 less than 4 times A. So can you put something here for C? 14 less than 4 times A.
So C equals 14 minus 4A.
What did we learn? I was going to say last week. It's been a long week. It was this week, like Monday or Tuesday, about the phrase 14 less at the back. Remember when you say such and such? You know, if I said 14 less than 100, you know, you would all know the 14 is subtracted behind the 100, huh? Right? We think better with numbers than we do with letters. We only get confused when they do it with a letter. But we know those English words mean subtract at the back, don't we? So 14 less means the 14 is subtracted at the back. What goes in the front?
4A.
4A. So 4A minus 14? Is that good, like that? So, okay, so they're saying angle C up here is 4A minus 14, and is the door locking? You're in the 7 a.m. class? 10 a.m. class, okay. Yeah, I noticed, I don't think you're on Math Excel, right? Oh, okay. Gotcha, understand. Yeah, we have a test today, so you could come take the test early on Monday before class, if you want. Yeah. So, yeah, okay, so you should, I'll double check it. If there's some reason you're not on Math Excel, I'm gonna drop it. Okay, good, I hope you feel better, thanks. All right, so we have 5 times A and 14 less than 4A. And then this one's just A. And, oh yeah, and we got to know a key fact, huh? Do you know all the angles in a triangle, what they add up to be? Oh, not Pythagorean. What do the angles add up to be? 180. I don't know if you know that. That's about the only geometry fact you'll need to know. Yeah, later we'll do the Pythagorean theorem. That's for the sides. But the 3 angles in any triangle add up to equal 180 degrees. So the 3 angles in any triangle add up to be 180 degrees. So that means that, bless you, that angle A alone, let me just do it this way. A plus B plus C are going to add up to 180. A is just going to stay A. What is B? 5A. And C is 4A minus 14. There's our formula. So we have A, B, and C, all in terms of one letter. See how we get them all in terms of A now? Because we can only solve for one letter at a time, huh? So there's our formula. That makes sense on that? So you just have to know, you put on your 3x5 card, or that, and the angles in a triangle always add to 180. That's what they're assuming you know. The three angles always add to 180 in a triangle. So A plus B, which is 5A, plus C, which is 4A minus 14, add up to equal 180. So there's our formula. And so now we just total that. So what's that going to be? A, 5A, and 4A? 10A? 10A minus 14 is 180? Because that was 1A, right? 1A and 5A is 6A, and 4A is 10A. 10A minus 14 is 180. We bring that somewhere else where I can finish it and run that room. Bring it over here maybe. So 10A minus 14 is 180. So solve for A. Add 14 to both sides. 10A is 194. Last step in solving for A. Divide by 10. A is 19.4. So A is 19.4. And they probably want all. Do they just want A?
Yeah.
Oh, I think they want them all. That's just the first one they asked for. They're going to ask for the others. So we got to get them all. So there's A. A is 19.4. How do we get B now? B, remember the B formula right there? 5 times A. So B is 5 times 19.4. B is whatever that is. 50 and 45, 95. Is it 97?
Yeah.
B is 97. See how I'm getting that? Am I going too quick? Is that making sense? So I solved for A, 19.4, plugged it into B, got 97. Now we got to get C. How am I going to get C? C equals 4A minus 14, huh? C is 4A minus 14. So plug in A. What is A? A is still 19.4. So C, if you work that out in your calculator, please tell me what you get. 63.6? Thank you. 63.6. So there's C, here's B, here's A. We got them all. Questions I can answer on that one? That one had a lot to it. So the three angles in a triangle always make 180. They told us that the B was 5A and C was 4A minus 14. So we did A plus B plus C, plugging in the formulas out to 180, solve for A, and then plugged in to get B and plugged in to get C. All right. Okay. Worker in a production line paid a base salary 180 plus 59 cents for each unit produced. How many units was? Yeah, you. I think this one would be easier to not use an X. I think. So So the base, and that's fine with me. Remember, I never care how you solve. I'm just trying to give you the easiest way. The base is 180, the base price, plus 59 cents per unit produced. So 59 cents per unit produced. 1 week. The worker earned $325, $325.73. How many units? How many units produced? So the base is 180 plus 59 per unit. How many units produced? I bet you could all do this problem without doing any x's, or it'd be easier without any x's, I think. How would we solve this without using any x's?
Subtract 180 from 325.
Yeah, does that make sense? Or are you just catching up with the problem still? Let me let you copy it down. Yeah, so if the worker earned $325.73, and they want us to figure out the how many units were produced. Remember, they get 180 base price, so they just pay them 180 base, and then they give them an additional 59 cents per unit produced, and they want us to find out how many units. So we could just subtract the base price, huh? The base pay, I mean. The base pay. 180. What's that going to be? 145.72. And then what do you do with that 145.72? Divide by 59 to see how many 59-cent pieces go into that. Does that make sense? Because that'll be how many units, right? Because the base pay was 180. So they were paid 180, and the extra stuff was all from the units produced at 59 cents each. Right? So they got a base pay of 180, so the 425.75 is what they got for the units. That's how much they got paid for their unit production, right? Was the 145.75. So divide that by 73. I'm messing that up, huh? Thanks. 73. 145.73, thank you. Divided by the 59 cents per unit. This is the per unit pay. And we'll figure out how many units. Hopefully that comes out clean. Is that nice? 47?
247.
247. And there we go. Is that good? I'm not even going to use an X. I think it's easier just to do it that way. They'll show you some way using X, which is fine. Either way is fine. Questions on that one? That makes sense? Just subtract the base pay. The rest is unit pay. Divide by the pay per unit. Get the number of units. Giving you a bunch of these percent increase, percent decrease. So there it is. So 10% tip. Cost including tip. Including tip, bless you, was 48.40. Find the cost of the meal before the tip. Find the cost of the meal before the tip. All right, so it's the same thing. It's when you give a tip, that's a percent increase, isn't it? Percent increase. What's the percent increase formula? X plus percent X is new. See how that is? You recognize that? When you see that percentage, right away think, oh, it must be percent increase or percent decrease, huh? All these word problems having percentages in them are percent increase or percent decrease. All right, so then X plus 10%, that's 0.10, X is the new price, 48.40. Is that good on that? All right, and then how do we solve that from there? What's in front of this X is a 1. Add those together. 1.10x is 48.40. So 1.10x is 48.40. Last step to solve for x. Divide by 1.10. 1.10. X equals, I don't know. 41? 44. 44. Must have been $44 before the tip. Is that good? Questions on that one? So percent increase, percent decrease, right? There's a whole bunch of percent increase, percent decrease problems. Tip is an increase, raise is an increase, sale is a decrease, right? All those that have percentages are percent. Tricky questions. They have a lot of tricky ones. All right. Malcolm, they're just being really tricky here. Paid $31 per tire, an average. So that's just crazy, first off. Where they're coming up with this average stuff. He paid an average of $31 per tire for 3 tires. Hold on for a minute. Do you realize they're giving you the total when they do that? Mm-hmm. If I said the average price, the average is 31 per tire for 3 tires. What does that mean the total is? 31 times 3, $93. Does that make sense? If something is an average for all 3, then you could just pretend all 3 have that amount and multiply by 3. That's what it means to be an average, right? So really by doing, that's just a sly way for them to tell you the total. They're just being tricky there. We're not done yet, but that's one crucial piece. Did you see that what I did there? The whole average thing. They're just being tricky. They're saying average of 31 per tire for 3 tires. Well, that means 93 is the total of those 3 tires. That's the total. I already wrote total. Right? Does that make sense? Something's an average. If I said, hey, what if Math Excel made different deals for different people? And I said, you know, depending on when you call Math Excel for your software, you're going to get a different price, right? Or maybe the bookstore is offering highs and lows throughout the day. But I said, okay, but 40 of you paid an average price of $60. How much did you pay total? Well, 40 times 60, right? If you paid an average. That's what average means, right? It's, it's all of them on average. I don't know how else to say that. So, right, that's the average. So if it's $31, so it's like they're each 31. They're not each 31. Some are higher than 31, some are lower than 31. But if you level them off, it's like they're all 31. All right, so 93 is the total. The price of one tie. Oh, these are ties. These aren't tires. These are ties. I got to read better. All right, these are ties. That's an expensive tie. Okay. One tie, the price of one tie was twice as much as another. So what does that mean? 2x. So the first, what's the first one? What's the first one in every word problem? X. So the second one is 2x, as they said twice. The remaining tie is, the third tie is just $24 straight. No x at all. Chuck with all that, that's kind of tricky, huh? So the first one's x, every word problem, right? Every word problem. Second one, they're saying twice. And the third one, $24. Okay, so what? What do these 3 all have to add up to be? 93, the total. So x plus 2x plus 24 is 93. Because 93 is the total. They're doing some tricks on that one. So there's our equation finally. Does that make sense on that? Did this course suddenly ramp up a bit? You can do this, but it will take time. It will take. This is a 15-unit class, right? 5 units done in 6 weeks is like taking 15 units. Here we are. This is going to take some time. All right, so there's our equation. X and 2x. Combine them because it's 1x and 2x. Like that. Yep, subtract the 24. So 3x equals, no, not 70, 69? So bring it over here. 3x is 69, last step. Divide by 3, x is 33? No, 23? Having a math problem. 23. All right, we got X, but what does that mean, the price of, well, you just go back up here. X is 23, and then 2 times X, 2 times 23, 46, and of course the last tire is 24. There's the price on the 3 tires. Does that make sense? I took that 23 for X, and I plugged it in here and here, right? 23 is all that is. 2 times 23, 46. There's that one. Now, what is it they're asking for? What was the price of the less expensive of the 2 remaining tires?
Ties. The ties.
Oh, ties. I keep saying tires, huh? Ties. The price of one tire was, those are cheap tires. It's a good price for tires. Expensive ties, though. Price of one tie was twice as much as another, and the remaining tie cost $24. So, yeah, one tie is twice as much as another, and the remaining tie is $24. What were the prices of the other 2 ties? Oh, the other 2. So there's the one that's $24. They want to know the price of these other 2, right? Because they already told you the $24 tie. So they want the other 2. So they're saying, all right, what's the less expensive of the other 2? Well, 23. And the more expensive of the other 2 would be 46. Woo! All that. And then average stuff? I mean, they could have just given us the total. But they were being tricky. So if they give you an average for 3 things, just multiply. And that's the total. That's what average means. It's like they all have that. I'm going to use an X. I'm just going to kind of think it's got 1,000,000 words. Number 11. All right. Hospital parking lot charges $3.50 for the first hour or part thereof, and $1.75 for each additional hour or part thereof. A weekly pass costs $47 and allows unlimited parking for 7 days. If each visit Johnny makes to the hospital lasts 3.5 hours, what is the minimum number of visits for which buying a pass will be less expensive than paying each time? That sounds really confusing. All right, really quick. So it's $3.50. This one doesn't need to be hard. Let me help. $3.50 for the first hour. That's the charge. And $1.75 each hour after that. Okay. Weekly pass is $47 and allows unlimited parking 7 days. That's for 7 days, week. Each visit Johnny makes hospital lasts 3.5 hours. So each visit is 3.5 hours. So if each visit Johnny makes to the hospital is 3.5 hours, what would be his charge if he just paid with the meters? Let's figure that out first off. Each visit is 3.5 hours, right? It's $3.50 for the first hour. $1.75, so this is the first hour. The second hour. The third hour is another $1.75. And the half hour, he's got to pay the whole $1.75. That's what they said. Each hour, they say each additional hour or part thereof. So you break into the next hour, they're charging you the $1.75. So if Johnny visits the hospital for 3.5 hours, he pays $3.50 for the first hour, and then $1.75 for the second, for the third, and the 3.5, the part of the fourth, another $1.75. So what's that add up to be? $8.75? Is that what it is? Thank you. So every time Johnny goes, he pays $8.75 per visit in parking fees. Is that making sense so far? I just added those up. $8.75 per visit when Johnny visits for 3.5 hours. So basically, what is the minimum number of visits for which buying a pass would be less? So basically, how many of these stays less than $47? That's what they're saying. How many visits, how many visits at $8.75 per is less or more? Well, more, because you want the weekly pass to be less. So how many would be more? More than $47. That's what they're really asking, right? They're saying how many of those would it take before Johnny would be better off just buying the pass? That's what they're really saying. So I would just take my calculator, Am I making any sense, right? They're saying, how many visits would make it better for Johnny just to buy the pass? The $47 pass. So how many 875 visits would actually go over 47 and he would be better to just buy the $47 pass? So I would just take my calculator and try it out. 875 times, what is it, 5 or 6? 6. What is 6? It's 52. So that goes over. 875 times 5 didn't go over. What's 875 times 5? 40 and... What is it? 4375. So that's not over. Yeah, so 6 days it's over. Everybody see how we did that? I just took 875, 6 days. If Johnny visits 6 times, it'll cost him $52. If he visits 5 times at $875 per visit, it'll cost him $43. So the pass is 47. So if Johnny's going to go 6 days, it'd be better to buy the pass. If he's only going to go 5 days or less, shouldn't buy the pass. So they're saying how many visits would make it less expensive to buy the pass? 6 days. 6 days or more, he'd be better to buy the pass. Does that make sense? No X, just all them numbers everywhere. All right? All those words can be intimidating. All right.